Hi guys, good morning.
Morning, sir.
I so much level so let's strength. We'll wait for people to join, then we'll start. Okay. Are you guys ready? We'll start.
Yes, sir.
Okay. Fine. So I think last class we stopped with photoelectric effect, isn't it? Can you just look at the notes and tell me where did we stop, guys? Last class, where did we stop? Did we stop with photoelectric effect?
We de Broglie's hypothesis, sir.
Oh, okay. We finished de Broglie's wavelength also. Okay. So did we get this equation? Lambda is equal to h by mv. This equation would have got,
Yes, sir.
right? Okay. So we'll do. We didn't do problems on this, isn't it? Okay. So we'll do some problems on this. Then we'll move on to the next topic. Okay. Take the question. Find the wavelength. Find the wavelength associated. Find the wavelength associated with a proton. Find the wavelength associated with a proton of mass 1.67 into 10 to the power minus 27 kgs. Mass is 1.67 into 10 to the power minus 27 kgs. And moving at a velocity of 1 into 10 to the power 3 meter per second. 1 into 10 to the power 3 meter per second. Okay, so they're asking you, that's the question. So find the wavelength associated, wavelength associated with a proton of mass 1.67 into 10 to the power minus 21 kgs, and moving with the velocity of 1 into 10 to the power 3 meter per second. I want the wavelength in terms of nanometers. I want the wavelength in terms of nanometers. That's the formula. Lambda is equal to h by mv. So like, see, if you can understand the beauty of this equation, right? So generally we say only waves, or say the some kind of rays only will have a lambda, that is wavelength or frequency, isn't it? So now what are you trying to do? You are trying to connect that particular aspect of a wave to a particle. Basically, proton is a particle, will have some mass. So, but again, if I go in terms of particles, particles will not have any wavelength or frequency. We can talk only in terms of their mass, isn't it? So this lambda term is for the wave, and this m term, that is the mass term, is for the particle, right? So basically, de Broglie's hypothesis connects both the particle nature and the wave nature of a particular substance, isn't it? And you get a beautiful equation like this: lambda is equal to h by mv, where lambda is the wave property and m is the particle property, and both these are kind of connected. Okay.
Yes, sir. I have a doubt, sir. The speed you told it as 1 into 10 power 3 or 10 power minus 3?
10 power minus 3. Velocity is 10 to the power minus 3.
H is the Planck's constant, right?
H is Planck's constant. Yes. It is 6.6 into 10 to the power minus 34. I asked you to change the value also, isn't it?
So this is an equation or formula, sir.
Equation, formula, everything is same only.
Then what value should they replace, sir, in place of MVH? Because we know all the values to replace it, so, sir. H value we know, M and V value we know. Then what?
Yeah. Lambda, you have to find the wavelength. That's what they're asking the question, right? Find the wavelength associated with the proton having so much mass and so much velocity. You have to find the wavelength of that particular proton. Lambda you have to find. Understood? Right? So it will be 6.6 into 10 to the power minus 34. H divided by m, that is 1.67 into 10 to the power 27 minus 27 into 10 to the power minus 3, right? So what will happen? 10 power minus 27, 10 power minus 3 will become 10 power minus 30, and 10 power minus 30 goes up, right? 10 power minus 30 goes up. Right, and I'll have basically 6.6 divided by 1.67 into 10 to the power minus 4. 10 to the power minus 4.
Sir, I'm getting 3.95, sir.
3.95. 1.6 divided by 6.67 is 3.95. Yeah, maybe it should be correct, approximately. Yeah, so 3.95 in 10 to the power minus 4 meters is what is the answer, right? So that is the wavelength of this proton moving with this much velocity. Okay, right? Fine. How many people are there? Okay, so many people are there. Okay, see, Some of you are actually involving in the class, right? And I would say most of you, I don't even know what you're doing. Okay, so how do we break this ice? You tell me. See, you're gonna be with me for this year and most probably next year also. Like for your 12th also, you might be with me. Okay, so what should we do? And most probably this online thing only is gonna continue, right? So there are almost 10 kids, but out of the only 3-4 kids are involving. What about the other 5-6 kids? Like I cannot let them be like that, right? So you tell me, how should we break the ice? How should I make it more interactive? All your suggestions are really welcome, right? What do you want to do? Tell me. Okay, like I think like okay. Can I ask people by pointing out their name? Okay, Pranav.
Yes, sir.
Do you have any idea how do we break this ice?
Let me think, sir.
Okay, fine. Okay, let me ask someone else then. Divya. Divya. No, I think it's not a problem. Divya is not responding. Okay, let me ask Mithun Krishna.
Sir, you can ask them to turn on the video, sir.
That's actually a very nice idea, right? That's what my brother's school and all, that's what they're doing during the online education. They should not switch off they should not mute, they should enable the video as well as audio. Shall we do that, or shall we do that, guys? Ella vandavalam thandavalam ella therinjum, isn't it?
Sir, parents will be doing photo bomb, sir.
See, that is actually a difficulty only. Like when we are in home, like there'll be a lot of people coming and going. Like you might not be able to like enable the audio and all that. But still, like if at all, like actually see, the thing is, when I'm physically there, I actually know what exactly you are doing. Like at least whether you understand or not, by looking at your face, by what reaction you give, I'll be able to understand what exactly is happening inside you. But since it is like this, even it's a new experience for me, right? I'm not able to guess unless and until, say, if I ask you, everybody understood, say 2-3 of you, or say yes. But I will not be able to get the overall judgment, isn't it? Like everybody understood or not. All this is actually a problem.
Sir, our school after finishing they ask questions, sir.
Okay. See, that is not the point, right? See, the thing is, if you have listened, whether I ask you questions or not, it is not going to matter much, because sometimes I will ask a question which is actually very tough, and just because you're not able to answer, and if I judge that you don't know or you didn't listen, that's actually a very bad thing, isn't it? So the thing is, instead of me asking you questions, if you ask me questions, no, see, I totally understand that till now, at least the first chapter was little okay, isn't it? It was all little logical and all that. So this chapter is also very logical, but the thing is, it involves a lot of scientific things, like a lot of new things which you're seeing for the first time, all that. So if at all I was in your place, I would have asked thousands and thousands of doubts to my faculty, right? So I don't know how you guys are trained in your school. Like I don't know. Like generally, when I was in school, also I was not that open to ask my doubts to my faculty. But it is not like that. You don't have to have any kind of say shell around you saying that okay, this might be not a good doubt, all that. So you don't have to have all these things in your mind, right? Say this is perfectly understood that you are looking at all these things for the first time, and it is completely okay to ask whatever the doubts you have, right? Say unless and until you are going to make this particular thing interactive, right? So like morning we are meeting, we are morning like 7 o'clock, almost early in the morning we are meeting. It is actually difficult. It is, I know that some of you are going for some other classes also, right? So the thing is, like rather than seeing this as a subject, rather than seeing it as a subject for which you have to study and score marks, at least that I don't teach that way, right? I teach chemistry. I teach chemistry as a subject in the sense for you to understand, not for you to get marks, right? Eventually, if you're going to understand everything with logical reasons, why exactly like this, why not like that, all these things, if you're going to able to bring it up, right, then actually it is going to work. Then actually we'll be able to have a very good conversation rather than me alone teaching, giving you a formula, giving you a problem, That is also going to be there. But the thing is, if you are also going to reciprocate, right, it is really going to be it is going to be helpful to a very great extent. Okay, so fine. So from now on, I think instead of asking you, hey, did you understand, I'm going to ask I'm going to point out people and then ask, hey, did you understand? And again it's going to be really easy, isn't it? I just have to say yes, sir. Okay, so we'll see, see yes.
Sir, sorry, sir. My microphone was not working, sir.
No problem, Divya. So do you have an idea how to break this ice?
Sir, I don't know, sir. Because chemistry is completely new to us this year.
Your chemistry is completely new to you. Yeah, that's what even I'm telling. Okay, regarding this chapter, this atomic structure, how many of you feel fascinated, and how many of you feel, oh God, what is this chapter? You can give me a very frank answer.
Mix of both, sir.
One second. Who's that? Who
Rohan,
spoke
sir.
now? Rohan. Okay, mix of both. Okay. What about others?
I actually like this chapter, sir.
Okay, you like this chapter. Nice. Bhavadarini, Mithun, Suryamuthu. What do you feel about this chapter?
It's fine, sir.
No, it's fine. You don't have a choice. Like, it is going to be fine. The thing is, whether you like it, are you enjoying, or you are like with so much difficulty, or are you listening to the class? That's what I'm trying to ask.
Both mixed, sir.
Okay, both mixed.
I'm not
Okay.
able to decide this easier.
The before chapter was more interesting, sir.
Before chapter was more interesting. Okay. See, the thing is, if at all you would have, what to say, you would have listened to this chapter with a still more open mind, no, without any judgments. Okay, like starting itself, we started with cathode ray experiment and all that. So it is, see, that's what, like, if you are going to have certain prejudgments before you start listening to the class, generally that entire chapter will be little weird only, right? So what I would suggest is, I am also trying to, what to say, even I am trying to go through the chapter, not like what to say, like I'm trying to bring it as a story rather than particular concepts, all that, because you can see the next topic I go, it is actually getting connected with the previous things, right? Say we saw first with your Dalton's model, then I told you how Dalton was disproved because the other subatomic particles were found out and how those were found out, right? And Thomson gave his model, and then Rutherford gave his model, and then how he was able to prove his own teacher's theory, right? And then we went on to see Planck is the one who was able to said that Newton's laws of motion will not work in certain cases. And based on that, Bohr gave his theory, and then we saw Bohr's model, and then we saw what are the problems with Bohr's model and how we are going to overcome that. What we are going to see, right? So what I would say is, please have an open mind whenever you go to a class, right? The motto should not be like, okay, he is teaching, I am listening. No, the motto should be, I should learn something new. That should be the motto of everyone, right? So it is very much obvious that from 10th to 11th is actually a very huge jump. I completely understand, because 10th you had only 5 chapters, right? So this one chapter was enough for your 5 chapters in 10th, isn't it? It is that big, is it not? Right? So all these are completely understood. But the thing is, do we have any choice, right? You wanted to take science, and that's why you took science group, right? And I don't know whether people told you that this is how it is going to be, or if at all you knew, maybe you would have taken a different group and all that. But since you took it now, right? So I would say, please embrace it, right? And you are not going to, like, see that certain things you'll study in 11th and 12th physics and chemistry are going to come along with you till the end of your life. I'm not joking, right? So this is not like a thing which you generally ask your teachers, like, sir, this I am learning, where am I going to use it? You will definitely use it, trust me, right? There are a lot of things, intentionally or unintentionally, you will actually be using all these things in your day-to-day life, especially if you're going to continue in science as your career, like say engineering or technology or whatever it is, even if it's MBBS, whatever it is, whatever the scientific field which you're going to be in, the basic 11th and 12th physics and chemistry which you're going to learn is actually going to be very, very helpful. That's what I'm trying to say, right? So like, please do have an open mind. Please do, before you come to the class, make up your mind that okay, sir is going to teach something very fascinating today, and I will be able to grasp all that and at least learn something out of it. It is not for the mark which you study here, right? If you're going to study for marks, that is one kind of motivation, but everybody will not have that motivation. Like, see, like getting 90 or 100 marks is not every kid's cup of tea, right? So someone will be getting only 60, 70 marks, but still the knowledge he has in that subject will be very, very high. Marks are not an indicator, I would say, at least according to me, marks are not the indicator of a student's potential, right? So it's all about what you perceive from the class, right? Whether you're trying to apply it anywhere, or if a good question is asked, how do you respond to the doubts, or how good doubts you ask the faculty. All those only determine what kind of knowledge you have in that particular subject. Okay, so and you don't have to have this thinking that I'm from 10th, I'm coming to 11th, it's actually a huge jump. It is a huge jump, everybody knows it, and every senior, every batch which passes out of 10th and comes to 11th actually feels this. You are not the first persons, right? But the thing is, nobody will be able to tell them, hey, it's okay, like this is how it is going to be for next 2 years, right? And you have to embrace it in the sense, accept it with all the heart, right? Until you are going to do that, how to put it, you will not have the motivation to study, right? And you will not have the motivation to listen to the class, or nor you will have the motivation to get marks also. Like, eventually whatever you are doing it for, the end result, that is a marks in the annual exam, that is also not going to be fruitful. There is going to be a lot of efforts, that I would say unintentional efforts. You don't want to take efforts, but still you take efforts just because it's a compulsion. It should not be like that, right? So since you like this subject so much, since you like some certain chapters so much, just because of that you have to study. That is how it is going to be. Okay, so from now on, I think I will point out to people to ask whether they understood, or whether yes, Mithun.
Sir, actually, in a school, you left one top, like what to say, you left one topic, sir.
Okay, which topic is relief?
Significant figures in the first lesson you left, sir.
Oh, significant figures and all, chumma kana, like that and all are not, they're not going to ask you, they're going to ask you in the exams also, and it is not that important also. Significant figures, maybe like they will tell after the decimal how many points are important and all that. It is really not important, and you are not going to use it anywhere in the problems also. So that is not an issue. Okay, so if you want me to teach, I can teach, it's not a big deal. But since you're a student in your school, it's very simple. Like, you don't have to worry much about it. You will study the same thing in physics also. So again, same thing, physics is first chapter, you will study about significant figures. Okay, so yeah, fine. So this class will use properly to get to know each other. Fine, we'll get to know in terms of chemistry only. Okay, fine. So let me ask, till now whatever we have seen, right? Shall I ask you some questions, some logical questions? We'll see whether you're able to answer or not. Shall we do that now?
Okay, sir.
Yes, sir.
Okay,
Yes, sir.
fine. Why everybody voice is so low? Should be so cheerful in the morning, waking up, listening to Akash's chemistry. Okay, so fine, let me start. Pranav,
Yes, sir.
can you tell me how did Thomson prove that the cathode rays are charged?
Yes, sir, I'll tell it lastly, sir. Let me think and I'll tell it last.
Okay, fine. Remember the question. Fine.
Yeah.
Okay. Bavadarni.
Yes, sir.
So can you tell me, in the cathode ray experiment, what was the role of the ZNS screen?
Sir, the cathode rays would fall on the via the anode, and it was used for 1 second, sir. the cathode rays would fall on the ZNS screen, and it was used to see the rays. It would
Okay.
glow if it falls on the
That's the point. That's the point. Correct. Correct. So basically, how will we know that something is moving from the cathode to anode, isn't it? Like we said that when the battery was switched on, right? So the rays were moving from cathode to anode, right? And how do we prove it? With the help of ZNS screen. When I keep the ZNS screen behind the anode, I saw some bright spots on the ZNS screen, indicating that something is moving from the cathode towards anode, and that's the role of the ZNS screen. Very good. Yes. Nice. Okay. We'll go to.
Sir, what was the question you asked me, sir?
Very nice. Okay. How did Thomson prove that the cathode rays are charged? They are made up of some charged particles.
Okay, sir. I'll think and tell.
Okay. Fine. Okay. Shruti.
Yes, sir.
Can you tell me what do you mean by a spectrum? And what are the two different types of spectrum we saw?
There are like continuous and line spectrum.
Okay, fine, correct. So where did we see continue? Like, okay, in what model did we introduce this term spectrum, Kanna?
In Rutherford's model, the
Okay.
same on the demerits. They expected a continuous, but they only got in reality they only got a line spectrum.
Exactly. So according to Rutherford, when his model, if his model is correct, what I expect is basically only continuous spectrum. But what I see in reality is a line spectrum, a single line, single energy value is going to be there. Okay, fine, correct. Okay, we'll move on to Abhishek.
Sir,
So can you tell me, Kanna, what question should I ask? Can you tell me about photoelectric effect? What happened in photoelectric effect and the equation of photoelectric effect?
1 second, sir.
Yeah.
Sir, emission of electrons during electromagnetic radiation.
Electromagnetic radiation on what?
Light.
Light is an electromagnetic radiation. Okay, and you said that light electrons are ejected out. There is one thing, something missing. How these are connected now?
When it hits a material.
Material. You're almost correct. But what material it is? It is any material or certain?
Sir, what is the
Someone
name?
wants to help him?
The metals.
Correct. So Abhishek, listen to Divya. He says it is. It should be a metal surface. Correct.
Okay,
So I have a metal surface. On top of it, the light rays falls, right? And the light rays will have some energy, and electrons are ejected out. Okay, fine. So what was the equation? Can you tell me, Kanna? Abhishek?
Yes, sir. 1 second.
Yeah.
Sir, I have a doubt in that, sir.
Okay.
Like vacuum chamber means like a little air will be there in it.
Yeah, partial vacuum. Inside the cathode ray tube, I maintain only partial vacuum because I obviously have some hydrogen gas also present, isn't it, inside the cathode ray tube? So it is not full vacuum, it is partial vacuum.
Okay, sir.
Yeah. So yes, Abhishek, can you tell me the formula? Did you write down the formula?
Yes, sir. I wrote, sir.
Ah,
1 second, sir.
yeah, okay.
Sir, HV equal to
Ah.
W. Sorry, sir. 10 seconds.
Okay, fine. You come up with this formula. I'll ask someone else before some questions.
Okay, sir.
Be ready,
Okay, sir.
Abhishek. In
Ah,
2
okay,
minutes. Okay, fine. Mithun Krishna. Mithun, are you there?
Sir,
Can you tell me what is threshold frequency in terms of photoelectric effect?
can
What
I say
is-
it again, sir?
Sorry?
Can I say it again, sir? I didn't hear properly, sir.
Oh, yeah. I'm asking you, what is threshold frequency?
Sir, threshold, sir, it is the minimum frequency which has to be possessed by the light for the photoelectric effect to happen.
Very good, very good. So basically, like I told you, this light is going to have certain energy, right? So obviously there should be enough energy for it is able to take out the electron, isn't it? So obviously energy is equal to h into nu, that is h into frequency, right? So obviously h is a constant. So if at all I need to have some minimum energy, I need to have some minimum frequency also, and that frequency, minimum frequency by which the photoelectric effect can happen, is what is called as threshold frequency. Okay, fine. Rohan.
Yes, sir.
Can you tell me? Can you just give me a gist of what Planck's quantization theory says?
Planck's quantization theories.
Yeah. Or at least whatever you understand from it. I don't expect the exact statements, but whatever you understand from it.
He told Newton's law is not applicable in subatomic level.
Okay, fine.
He gave a theory about black bodies which can absorb or emit any frequency.
Correct. That is what at least is thought, isn't it?
Yes.
Black body, an ideal black body was basically understood as something which will be able to absorb any amount of energy and it will be able to emit any amount of energy.
Yes, sir.
Right. And what Planck said about it?
Planck told only a certain particular amount of energy could be absorbed or emitted.
Okay, fine, correct. Okay, so and how are we going to decide these particular values which you're talking about? What you told is correct. So obviously not all the energy are emitted out, right? There will only certain permitted values, right, which are going to be absorbed or released for that matter. That the question is, how are you going to decide these values?
Through fundamental values.
Correct, exactly, super, coming up, good, go on. So with the help of fundamental value, what do we do? What is the fundamental value called as?
The fundamental value is called quanta.
Super. Quanta means a packet of energy, right? So that is going to be the minimum energy which can be absorbed or released by that black body. Or if I talk in terms of atom, it can be the minimum energy possessed by the electron. Correct? Okay.
Yes,
so now how are the permitted values, other permitted values based on this quanta?
They're based on an integral multiple, sir.
Exactly. Correct. Very good. So basically, if at all the quanta value is some 2, right? The other permitted values can be 2 into n, where n is an integer.
Okay.
Right. So basically, all the allowed values which are so basically, I hope you understand, guys, what we're talking about here. So we're talking about Planck's theory, right? So Planck's theory, what happened is, before that, a black body was thought to be something which can accept or release any amount of energy. But Planck said, no, it is not like that. It is like it can absorb or release energy, but not all values. Only certain permitted values are there, right? So that permitted values are going to depend upon the smallest value. The smallest value is what is going to be called as a quanta. right? And based on that smallest value, all the other permitted values are going to be integral multiples of this particular smallest value. So it will be, if at all, if the quanta value is E, all the other values that are allowed are going to be n into E. So say it's 1E, 2E, 3E, 4E, 5E, like I cannot have a value like 2.5E or 3.5E. No, I cannot have a value like that. That value is not permitted. Only integral multiples are permitted. Okay, very good, Rohan. Very good. Okay, we'll move on to Surya Muthu.
Yes, sir.
Surya Muthu, can you tell me? Okay, so we say that stability of an atom is in question when I go for Rutherford's model, isn't it? Stability is one of the main demerits we saw for Rutherford's model, isn't it?
Yes,
Right?
sir.
Can you elaborate on that? How stability is a question? Why, according to Rutherford's model, I expect that the stability will not be there?
One minute, sir.
Yeah. So I think someone asked me to wait. Who was it? Abhishek? Are you ready, Kanna?
Yes,
Abhishek,
sir. Yes,
Pranav
sir.
also.
Yes,
H.
sir. Ready, sir.
Yes. Tell me, Kanna, Pranav. You can think about your answer. I asked question to who? Surya Muthu.
Yes, sir.
Okay. Surya, you can think about the answer.
Okay.
Till that time, Pranav will answer the question.
Shall I, sir?
Yes, yes. What question did I ask you, Pranav?
Like how cathode rays can be.
Okay. How is it? How did you discover that it is like made up of negatively charged particles? Yes, Pranav, tell me.
Yeah, sir. When the electrical field is applied, sir, the electrons just move on, and there will be some electric plates and some magnetic fields that are perpendicular to each other, which makes them to get deviated and just reflect on the fluorescent skin and like points as much as how.
Okay. Fine. Correct. So what happens is, say if at all I have cathode rays. So what happens is cathode rays in the absence of any external electric field. So only electric field I have is, so here is one cathode, here is one anode, right? And the cathode rays were moving in straight lines. Correct. But if I'm going to apply any external electric field, say I have one more battery is connected now. External electric field is applied.
I
Now
meant it as
what is
electric plates, sir.
Sorry?
I meant it as electric plates.
Correct. These are electric plates. These are two electric plates connected to the battery. Yes, that's what electric field only basically. Right? Okay. So now what is going to happen is this cathode rays are going to bend towards one of the electrode. They're not going to move in straight line anymore, right? They are going to little deviate from their straight line path. Right? Fine. So this proves that the cathode rays are charged. Now, depending on which side, basically two sides it can bend. Either it can bend this side, right? Or it can bend this side, not both sides, right? Either that side or this side. Correct. Now I can go to the question of, okay, I understand it is charged, but what charge it is? Whether it is positively charged or negatively charged, that depends on which side it is bending. Correct. So if at all I see this, I have connected positive terminal of the battery, negative terminal, positive terminal, negative terminal, and it is connected here. Okay. Now what I saw, which side it was bending? Towards positive side or negative side?
Negative side.
Towards positive side. Why? Because cathode rays are negatively charged. It will bend towards the oppositely charged electrode. See, opposite charges attract.
Cations are just opposite of that, no, sir?
Yes, cations are positively charged. But what are cathode rays made up of? What are cathode rays made up of?
Positively charged.
Cathode rays
Okay, negative. Yeah, negative.
Cathode rays are made up of basically electrons, isn't it? Negatively charged. So they will bend towards the positive electrode. So in this case, positive electrode is here, right? So it will bend towards this side. All these will bend towards the positive electrode, right? So this is how Thomson concluded that the cathode rays are made up of negatively charged particles, because they are, whenever an external electric field is applied, the cathode rays are bending towards positive electrode, indicating that it is a negative charged. Okay, fine. I think another person who was waiting was Abhishek. Are you ready, Kanna?
Sir, HV equal to HU plus half MV square.
It's h nu is equal to
H nu.
H nu naught, not H u.
Okay, sir.
H nu is equal to H nu naught plus half mv squared. Okay.
Okay.
Fine. Can you explain this equation? How is it like this, Abhishek?
Sir,
Okay, fine. I will not trouble you so much. Fine. I'll ask someone else. So, okay, fine. I asked someone else. I think Surya, I asked you a question. Yes.
Actually, sir, in Rutherford's model, it states that electrons would eventually fall into the nucleus.
Okay. Can you?
So
Okay, correct. He didn't say that. See, that was what we understood
concluded.
from it. We concluded because that is what is exactly the problem with stability.
Yes, sir.
What he told that we have to decide like that.
I don't get you, sir.
Like basically, you are telling, right? Eventually, the electron will fall into the nucleus. Right?
Yes,
Out
sir.
of nowhere, it will fall into the nucleus. Definitely, Rutherford had told something, and
He
then we'd have
told
understood.
that electrons would eventually lose energy.
That and all again, he didn't say. Well, the only statement he said, what statement he said regarding electrons? About its movement, what did he say?
I don't remember, sir.
Anybody else? What did Rutherford say about the movement of
Electrons revolve around the nucleus.
Exactly. That's a very simple answer. Electrons will be continuously revolving around the nucleus. Okay. So if they continuously revolve around the nucleus, what will happen? Say initially they will have some amount of energy, and they have to go round and round and round around the nucleus. That too, they have to overcome the force of attraction also. Nucleus and the electron. Nucleus is positively charged. Electrons are negatively charged. So already the nucleus is pulling the electron towards itself. And he said that the electron is continuously revolving around the nucleus. So obviously at a point of time, the electron will lose all its energy and it will fall into the nucleus. That is how the nucleus is going. That is how the electron is going to fall into the nucleus. It's not like Rutherford didn't tell anything about the energy or anything about the stability of the atom. From whatever he said that electrons are going to continuously revolve around the nucleus. And by logical reasoning, we understood that if at all it is going to continuously revolve, it will definitely lose all its energy and it will fall into the nucleus. Understood, Abhishek? Abhishek?
You are Suryamuthu, sir.
Oh, okay. Sorry. Suryamithu, understood?
Yes, sir.
Okay, fine. We'll go to another question. Whom should I ask? Okay, Divya?
Yes, sir.
Fine. So I was asking someone, can you explain this equation, how it came? This H nu is equal to H nu naught is equal to half mv squared. Can you explain how this came?
Each material has a work function, sir.
Okay, cool, nice.
So energy of light is equal to H mu.
Energy, sorry, I didn't get you.
Energy of light, sir.
Energy of light is H nu. Okay, correct.
Photon thing.
Energy
What do we call the work function as?
Work function is this H nu naught. So basically threshold energy is what you have is, right? This threshold energy is what is called as the work function, right? See, how do we understand it? Okay, now let me give you a case like this. Like
Sir,
actually
that's like the energy required to eject the electron only, no, sir?
not exactly. Wait, it's almost like that, but you look at this. Okay, say I have a box, right? In that I have a pile of balls present. There are a pile of balls. Okay. Now what I'm going to do is I am going to throw another ball right at the edge of this. Right? I am going to throw another ball right at the edge of this. Now what do you think will happen?
Everything will fall down.
Okay. I made sure that this is very strong. Okay, this thing is very strong. So if I hit this, can I say the force will move up, and this particular thing I have here can get ejected?
Yes, sir.
Can you imagine what I'm saying?
Yes, sir.
Right? So basically, I have a stone and I'm putting it at the bottom of this cluster, right? So when this hits and the top one goes out, say another time hit, another top one goes out. So please understand this. Okay. Now what are we trying to say? If I throw it very slowly, if I throw it like very, very slowly, I throw it, and definitely nothing is going to happen. right? If at all I want this ball to come out, if at all I want this stone to come out, I have to hit it very fast, right? So how much force which you have to apply is what is my work function analogy I can give to my photoelectric effect. Like if these are all electrons and this is my light ray which is falling, it will have some energy, right? So the energy has to be little higher than the force of attraction which exists between these electrons here, right? So basically nucleus will be there and some electrons will be there and they will have some force of attraction, right? So the energy which you are going to give, two things it has to do. First, it has to break up this thing. Or
Threshold.
the force of it has to break up the force of attraction. That force of attraction, that binding energy between what? Between the nucleus and the electron. This is what is called as work function. Right? How much energy they have, how much force of attraction they have, the binding energy between the nucleus and the electron is what is called as my work function. Right? Obviously, the amount of energy you spent, right, amount of energy the light rays is incident on should be greater than the work function. Right? It definitely should be greater than the work function, and this work function is nothing but h nu naught, and nu naught is the threshold frequency. Okay. Fine, continue. So h nu is equal to h nu naught, and last what do you have?
So, sir, E is equal to, that is energy of light will be equal to the work function. With no photoelectric effect.
Can you repeat after work function?
Yeah, sir. There will be no photoelectric effect happening, sir.
Okay, correct. So if at all the energy is
So the energy of the light will be greater than the work function.
Super. The energy of the light should be greater than the threshold work functions for photoelectric effect to happen. Correct. Okay. Fine. So if at all now the energy is greater. Okay, now the energy is greater than the energy supplied is greater than the threshold energy, or say the work function. Right? So yes, continue.
H mu will be equal to h into mu naught plus the kinetic energy of the electrons.
Correct. So obviously now some extra energy you spent, the amount of energy you spent is greater than the threshold energy. So where is the extra energy going to go? Now a law of conservation of energy should be satisfied. Energy can neither be created nor be destroyed. So how much ever you give, should all the energy should be used up in some way. Correct. So some amount of energy used up for overcoming the binding energy, that is the work function. Right? What about the extra energy you supply? Now that extra energy is going to go to the electron, which is going to come out in the form of kinetic energy, because the electrons are moving now. That is why we put half mv squared. Right? So this basically is an energy conservation equation. Right? Whatever energy you supply should be used up. So that is the total amount of energy. Some amount of energy used for overcoming the work function, and some amount of energy is going to go for kinetic energy of the electron. Okay. Yes, good, Divya. Good. Okay. Fine. Fine. Whom should I ask? Fine. Rohan?
Yes, sir.
Okay. What question should I ask you? Fine. Let me see if you remember this. We say that in the absence of electric field, in the absence of external electric field, I told you that the cathode rays are going to move in straight line, isn't it?
Sir.
How will you prove it, Kanna? How
We'll
is it
put
that
zinc sulfide one plate we'll put at the end of the anode, sir.
Okay, say
And then
okay, I understand what
behind
you're
the
trying to
anode.
behind the anode. Say
The
now the
anode
ZNS,
holes,
ZNS I understand. So ZNS screen is here. Okay.
Okay, sir.
Now I tell that if say this is a straight line path. Okay. Now
sir.
what if the electron is moving like this and exactly hitting the center? Then also it is at the same point, the bright spot which I'm going to get on certain screen.
Yeah.
I told you this. How are we going to prove that it actually moves in straight line? Anybody wants to join the conversation? Anybody has an idea? How did we prove it?
Sir, you told something is used, sir. Some instrument.
Yeah. Not instrument. It's basic logical explanation only. Shruti.
We did like put another circuit.
Circuit. That is for deflection. That is for this thing. What is that? To prove that they are charged particles.
Okay.
So
Sir,
to
you
prove
told
that,
something like when the rays hit, something will move, sir. So it shows that it's a ray.
no, like now it is not the question of whether it is going to be a wave or a particle. That we'll see later. What I'm asking is whether it's a wave or a particle for that matter. What is it? Thomson concluded that they move in straight lines. How did he prove it? That's what I'm asking.
They gave shadows.
Yes, that was what I was expecting. Wonderful. So basically, what I tell you, we know that the light rays are actually moving in straight lines, right? So if I stand at the path of the light, what happens to my shadow? My shadow will be exactly on the same size as the object, isn't it? If I am going to stand, if at all the rays come in straight lines, right, the shadow is going to be of the exact shape and exact length. Correct? So what happened? Now, if at all they move in straight lines, and if I place an object, some star, something, so whatever the shape of particle I place, right, the shadow of this particle is exactly same. I mean, the shadow which is getting formed on the screen will be exactly similar to the shape and size of this particular substance.
Yes, sir.
And that is how I prove that the straight lines, I mean, the cathode rays move in straight lines.
Understood,
Correct?
sir.
Okay,
Correct.
very good, very good. Fine. Whom should I ask? I will ask Pranav.
Yes, sir. Yes, sir.
Pranav, can you tell me? Okay. Thomson concluded that this cathode rays are made up of particles and not waves. Right? The cathode rays are made up of particles and not waves. Can you tell me how he proved it? I'll give you a clue also. The clue is E is equal to mc squared.
I guess I forgot it, sir.
Okay, fine. Someone wants to try? How did Thomson prove that cathode rays are made up of particles and not waves?
He kept a paddle like a cycle thing,
Yes,
so
very
when
good.
the rays hit it, the paddle moves, so which means it is made up of particles.
According to which equation?
Like E
According to
Equal to
exactly,
MC.
because if at all I had the race has to have some energy in order for the paddle wheel to rotate, isn't it? And at that time, according to Einstein, only if I have some mass, that mass can be converted into energy, right? So according to the equation, E is equal to mc squared. So this proves that cathode rays are made up of particles. Okay, fine. Okay. Next. Okay, Bhavadarini.
Yes, sir.
Can you tell me what is the formula for finding ionization energy of an element according to Bohr's model?
Yes, sir. 1 second. So the ionization energy is...
Okay, first, one second. First, define ionization energy and then give me the formula.
Okay, sir. Ionization energy is the energy required to take out electron from first orbit to the infinity orbit.
Okay, very good. Fine. Correct. Okay. What is the formula?
So that 2.18, that thing, sir.
Okay. Yeah, correct. 2.18 into 10 to the power?
Into 10 to the power minus 18.
Minus 18. Okay. Okay. Correct.
Z squares.
Okay. Correct. Right. So ionization energy, you can just remember it as K into Z square. Right. So K value will depend on what kind of unit which I'm going to get. If at all it is joules, it is 2.18 in 10 to the power minus 18 in terms of joules, or it is 13.6 in
13.6.
terms of electron volts.
Yes.
Okay, fine. Shruti, not Shruti, I mean, Vavadharani, last question. Like, how is it different? How this ionization energy is different from what we see now? Basically, now in your periodic table also you have studied about ionization energy and all that, right?
Yes, sir.
Can you tell me what is the difference between that ionization energy and this ionization energy? Did you study ionization energy in your 10th? You studied, right, ionization energy in 10th?
Yes, sir.
Periodic table. Tell me.
So this ionization energy is taking the electron from the first orbit to the infinite orbit.
Okay.
That ionization energy is
So can I try?
Wait. Let us try.
So the energy between the ions, sir.
Okay, you did almost correct. Okay, who wants to try?
Sir, like in 10th we studied was like it was say based on some electricity, sir.
Electricity.
That ionization.
Okay, what exactly is the definition which you will give for ionization energy?
To transfer electrons from one shell to another, it doesn't specify which shell, sir.
Minimum amount of energy required
how much of energy required?
To move the electron from the valence, electron.
Valence shell. That's it. It is the energy required to take out the electron from the valence shell. That's it.
Yes.
Like from the valence shell, I have to take out the electron. That's it. Take out means what? Out of the atom. And where am I taking it from? I'm taking it from the valence shell.
Valence electron.
But here what I'm doing in case of Bohr's theory, I am taking out the electron from the first orbit. Always and every time it is only the first orbit in case of ionization energy. But a normal ionization energy studied in the previous classes, that specifies it from the valence shell, the last shell of the atom. From that I take the electron. That is the only difference. Understood, Bhavadharni?
Yes, sir.
Okay. Pranav, did you understand?
Yes, sir.
It's I told the 9th one answer, sir. 9th I studied one thing, sir. Same ionization of energy. I told that answer.
Okay, fine. No problem. Fine. Whom should I ask? Okay. Can I ask Divya?
Yes, sir.
Divya. So tell me, what is the main problem? One big problem we face with Bohr's theory.
So only one elements having one electron can be identified using.
Okay, I can have only elements. Can I have any ions?
No, sir.
I cannot have any ions. How is it that two elements, say for example, you told that...
Sir, it has dual nature, sir, both particle nature and wave nature.
No. Do not confuse this thing and that thing. So what I'm asking is, what you told is correct. Like one of the main problem with Bohr's theory is that it will work only for single electron. It is not elements. Because can you tell me two elements having one electron in them? Can you tell me two elements which have
hydrogen
and helium? Hydrogen has one electron. What is the atomic number of helium?
Plus.
Atomic number of helium is 2. That means how many electrons it has? 2 electrons. So it should not be elements. You should not use the term elements there. You should use the term single electron species. It can be elements or it can be ions. How it can be ions? Say for example, if I take He plus, right? What happens in He plus? I have 2 electrons in helium. Correct? One second. I have 2 electrons in helium, right? So how do I make it He plus? I want to make something. And there is something neutral, and I want to make it positive. What should I remove? I should remove a negative charge, right? So obviously, if I want to convert He to He plus, 1 electron is lost, right? Now this can be work. This can work for Bohr's atomic theory because now initially it had 2 electrons. Now it has only 1 electron in it. Same goes with Li2 plus. Now lithium had 3 electrons in it. Correct? Now lithium had 3 electrons. So from lithium, if I remove 2 electrons, so it will have only 1 electron. So it will be Li2 plus. Now Li2 plus, He plus, hydrogen, De3 plus, all these are single electron species. Okay, and only for these kind of species Bohr's theory will work. Right? Okay, so this was the main problem what I faced with Bohr's theory. There are certain other problems. Okay, fine. What other question should I ask? Okay, so whom should I ask first? I'll decide. I will ask Abhishek.
Sir.
Okay. What should be asked? Okay. So you remember, first tell me who was the scientist who found out or who discovered protons, Kanna, Abhishek?
Once again, sir, I will think, sir.
Yeah. Okay, this is an easy question. Can someone tell me who was the scientist? Next question is coming for you, Abhishek. Yeah, Goldstein. Goldstein was the scientist. Okay. Fine, Abhishek. Now can you tell me how it was discovered? How protons were discovered?
One second, sir. Sir, Goldstein. One second. Sir, Goldstein discovered the existence of positively charged rays in the tube, sir, by using a perforated cathode, sir.
That is what I want. So the term perforated cathode. Okay, don't mind me asking, Abhishek. Are you using Google?
No, sir. I wrote it here, sir.
Okay, fine. I trust you. Okay, fine, because the way with which you told, no, like you're looking at something and reading. That's why. Anyways, so what you told is correct, right? So the thing is, okay, it is exactly the experiment which Goldstein conducted is exactly similar to the experiment of Thomson, cathode rays experiment. But in Thomson's, basically, it is moving from cathode to anode. So anode has a hole, right? Perforated anode I used in case of Thomson. And in terms of Goldstein, I had again cathode and anode only, right? But here it is moving from cathode to anode. Here the rays were moving from anode to cathode, and in this case I had perforated cathode. What do you mean perforated? Having some holes on the cathode, right? Obviously the rays cannot penetrate the cathode or anode and go hit the certain screen. I obviously need to put some holes, both in my Thomson as well as your Goldstein's proton as well as Thomson's electron. Okay, fine. So guys, that's it. Okay, so did you, one second, just give me a moment. Okay, now did you find it interesting, this chapter?
Yes, sir.
Exactly. So the thing is, it's all about how interactive it is, right? See, like I might, now that I'm not able to see you, but still I can understand that everybody is able to enjoy the class, everybody is interested in the class. All that I'm also able to feel it is because you are also showing some interest. That's exactly how it is, right? So now from now on, if you don't understand anything, like if at all any logical question, any scientific explanation, or whatever it is, if I know, I will definitely tell you. If I don't know, I will tell you that, please guys, I will let you know in the tomorrow's class, and I will let you know. That is the point, right? And if I ask you a question, if you didn't know, you must have the feeling that you would answer for next class or in some time I should answer this question. That kind of curiosity should come, right? So can I expect a difference from next class, guys?
Sir.
Right? Okay, so all of you will participate no matter what. No matter what, all of you will participate. When I give a problem, all of you will try the calculation and all of you will compete among yourself to give me the answer. Is that okay? Right? Fine. We'll see. Tomorrow also we have a class. Let me see if I have a difference. Almost 1 hour I spent in motivating you. Please. Okay.
So
Right?
same morning class, sir, tomorrow.
Tomorrow same morning class karna 7 to 8.
Okay,
Yes.
sir.
Okay,
Okay.
sir.
So today we didn't see anything. Today is just free day. We got to know about each other. We got to know how to study. We got to know about so many things today, right? So we will, from tomorrow's class, we'll start teaching again, and it is going to, I hope it will be different, right? Fine then. Thank you. We'll
Yes,
meet
sir.
again.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank
Yeah.
you, sir.